So here we've got another reaction mechanism for the reaction W plus Y to make Z. In this mechanism, you've actually got 3 steps. W turns into R, which is the first step. Step 2, R reacts with Y to make Q. And in the third step, Q makes Z. Now what we've added this time are some relative rates of each of these elementary reactions. You'll notice that step 1 is labeled as the slow reaction, the slow elementary reaction, where step 2 and step 3 are the fast elementary reactions. As for which of these is faster, who cares? Because think of it as being on an interstate. If there's a slow car in front of you and you're stuck in that lane, you may only go as fast as that car that's in front of you. So since step 1 is our slow reaction of this mechanism, we don't care about the speeds of step 2 or step 3. This slow reaction is what's called the rate determining reaction. Since it is the slow one, it determines the rate for the entire reaction. Now, before we dive any deeper into that, I just want to take a look. W in step 1 turns into R, and R, since it is immediately consumed in step 2, is an intermediate. So we have an intermediate of R. Then in step 2, Q is produced, and then immediately consumed in step 3. So we also have Q as an intermediate. And since there is nothing present both at the beginning and at the end, there is no catalyst for this reaction. So what we can do now is we can actually write a rate law based off of this slow or rate determining step. Since this is the slow step and it determines the rate law is entirely determined by the rate determining step, this slow step here. So we know our rate law is going to be rate equals K. And then again, step 2 and step 3 are irrelevant because they're fast reactions in the scheme of things here. The rate law is only based off of the reactants of the slow step. The only reactant in the slow step is W. So we can say that the rate of this reaction is going to be equal to K times the concentration of W. Now what about the reaction order up top, the exponent rather? The exponent of this W is going to be derived from the coefficient out front in that rate determining step. You cannot come up here to the overall reaction and take its coefficient, but you have to take the coefficient of the rate determining step. Well, in the rate determining step, W has a coefficient of 1, so we could, I suppose, write in a 1 here so we know it's first order with respect to W, but you don't actually have to because it's understood. So what we've just done is we've taken our slow step and we've converted it into a rate law for this reaction.